Okay, so we've got a school with 1,250 people. It's decreasing at 3% per year. What will the population be 5 years from now? So no, yeah, I know we're used to it increasing in our district, but it decreasing just about everywhere else. So yes, really.
Is it going to be negative 0.03?
That's exactly right. So when we're decreasing now, when we fill in the formula, it's going to be 1,250 students that we start with, and it's 1, but it'll be a negative because we're decreasing at 0.03, and it's annually, so it's just 1, and 1 times 5. Okay, so you don't need to put that in there, but it helps remind you not to forget about the that n. So it looks like there'll be about 1,073 students, 1,073.4, but of course we won't count the fractional student. Yeah, 0.4.
Is it going to be bigger or smaller?
Well, they're just a grade 8, that's all. 0.4 of a student, they must be a grade 8. Okay. So see if you can solve, I know last time it sounded like a few of you had some difficulty there. See if you can solve for when there will be 900 students at this school. Okay, so I'll try to walk you through it if you had some difficulties on the first one. But this is the equation that we're working with. We could leave it as 0.97, and we don't know what time this is going to occur, so that's what we're trying to solve for. So 900 divided by 1250, that's 0.72. And now I can use a log to figure out what that exponent is. So that'll be the log in base 0.97 of 0.72 equals t. And of course I need to change a base rule, so in my calculator it's going to look like this. And that gives me a time of 0.72, about 11 years. I get 10.785, but it'd be about 11 years. Next, on the 11th year, they would open with less than 900 students. Okay, so other than compounding interest, this is the formula that's used probably most often. And the way this works, these things are the same. This is the amount at a given time, and the initial amount. And we said this was the initial amount. So C is what we're going to call the growth constant. And T, this is the time elapsed. And P is the growth period. So these two things are connected. Sorry?
Is P like N?
No, I'll explain it to you in a second. But they're connected. So for example, you might hear something like doubles every 50 days. And what that would mean is doubles, C equals 2. Every 50 days, it's connected to the growth, so this must be the period of 50. So 1 tells you they're connected because it doubles every 50 days. So the formula is pretty easy to use. It's easier to use it than it is to write all the stuff out for it. Let's try one just so you get a chance to see what I mean. Okay. Initial amount. Yeah. Can I go up? Sure. I'll go back up for a second.
Will you give us these formulas during the quiz?
You won't have them for the quiz, no. That's usually the Math 11 math. Okay, So strontium-90 has a half-life of 28.1 years. How much of 400 grams will remain after 200 years? So it doesn't sound that friendly, I guess. But let's figure out what we've got here. Can anybody tell me what the growth constant is? 1/2, because that's how the object changes. It's halving. And what's the growth period? 28.1. It halves itself every 28.1 years. We start with 400 grams, and we half it every 28.1. And I would like to know how much is left after 200. So one thing that you should think of to help you remember the way the formula works is basically this fraction tells you how many times it will half itself. So for example, if exactly 28.1 years went by, how much of that 400 grams would you expect to have? 200. Because it's halved itself exactly once. 28.1 divided by 28.1 would tell you to half it once. Okay, you're going to be real difficult this time. 56.2 years go by. How much do you think would be left? 100, because it's halved itself twice. So that's how you can tell this fraction tells you how many times it's going to apply that growth constant. So I have 2.88 grams, that's all that's left. Okay, so something else that can grow exponentially, bacteria culture has 850 bacteria. How many members would be there if it doubles every 5 hours? Assuming unrestricted growth and complete survival, how many will be there after 24 hours in the petri dish? So you probably don't want to count them by hand, by the way. So at some point you're going to want to make some sort of model for growth. Yeah, you count. Yeah. Well, they're probably paying you by the hour. That's why you want to count it by hand, right? Okay, so let's see if you're getting the hang of this. There's 850 bacteria, and it's doubling every 5 hours. So that's my fraction, is every 5 it gets doubled. 24 hours has gone by according to this problem. So 850 times 2 to the, let's see here, we're going to need some brackets, 24 over 5. There should be about, only 24,000, well, let's not round it, we'll keep it at 23. There should be about 23,678 let's say 98. So almost an extra one there, but quite a few bacteria. When will the population reach 1 million? So because these things, that's why when you do have an infection, it's so critical that you get antibiotics quickly, is you don't want it just getting out of control. So let's see, if I want 1 million items, 1 million has 6 zeros, and it starts with 850, and it's going to double every 5 hours. So I'm looking for that value up there. So if we were to rearrange this, 1 million divided by 850 is, well, 1176.47085. I'm going to just save that in the calculator so I don't have to keep typing it. And now I can use my logarithm. This will be the log base 2 of 1176, and I'll just put the ... there, equals x over 5. So x equals, and I need to use change of base here, so it'll be the log of 1176 going over the log of 2. So it looks like it's only going to take about 51 hours to hit 1 million, which means, I don't know how bad that is. Hopefully it's not like in your arm when it reaches 1 million. But, that's like just over 3 days, and the population has swelled that much. Okay, so here's a couple of questions. I'm going to let you work ahead and see how you do with these on your own. This one is very similar. This one is now solving for the half-life, which means you're going to try to solve it for the growth constant. So give those a try. We'll recap together.